Hi guys, my name is Peter C. Duggar Jr., mathematics instructor at the University of Liberia and your math tutor. In my today's lecture, I will be discussing differential equations, and under differential equations, we will be looking at eliminating arbitrary constants to arrive at differential equations. So in previous videos, we did eliminating arbitrary constants. We solved like 2 examples. In this problem, we want to solve the third example problem. So we told you in the previous video that whenever you have a functional relation, a kind of relation of this form or a kind of function of this form, what you need to identify is how many constants have been given to you in the problem. Do you have one constant? Do you have two constants? Do you have 3, 4, 5, and so forth? Because the number of constants within the problem given is the number of derivatives that you must arrive at. So if you have one constant, it means you have to differentiate once. If you have 2, you must differentiate twice. You have 3, you must differentiate 3 times, and so forth. So in this problem now, we have 2 constants. So it means this is a second order differential equation solution. So we must differentiate twice to be able to arrive at the differential equation that has this solution. So let's get started. Now, the first derivative, y prime equals, now this is just a constant, so it gives us 0 plus c sub 2 e raised to the power 3x. Now we know that if y is equal to e raised to the power ax, it means that y prime will be equal to a e raised to the power ax. That is, whenever you have an exponential function to find its derivative, rewrite the entire exponential function and differentiate the power. So the derivative of ax is just equal to a. Even if you had e raised to the power x squared plus 3x plus 2, you rewrite it and you differentiate the power 2x plus 3. So we do the same for this. This is c sub 2. We rewrite e raised to the power 3x times we differentiate the power. The derivative of 3x is just 2, it's just 3. So we can simplify, we have 3c2 e raised to the power 3x. So we've gotten the first derivative. We move to the second derivative, prime is equals. So we rewrite 3c2 and then we differentiate. Again, we rewrite e raised to the power 3x. And then we differentiate the power, which is just 3. So y prime is equals to 3c2. So 3 times 3 in fact is 9. So it's 9c2 e raised to the power 3x. Now, we could call this our differential equation, but remember, we do not, need any constant, any arbitrary constant in our final answer. So we must solve for this arbitrary constant C2. So we know from this equation, we call this equation 2, we can call this equation 1 and equation 3. So we know from equation 2 that y prime is equals to 3c2 e raised to the power 3x. So we can easily solve for c2 by dividing both sides by 3 e raised to the power 3x. So we will have c2 to be y prime all over 3 e raised to the power 3x. So with this now, we can replace within equation 3. So it's y prime equals to 9c2 e raised to the power 3x. So this is just going to be replaced 9. So this is now y prime all over 3 e raised to the power 3x times e raised to the power 3x. So e raised to the power 3x can cancel this. 3 here 1 times 3 into this 3 times. So y prime is 3. Y prime is 3y prime. We can rewrite it by putting all of the function on one side. So you got y prime minus 3y prime is equal to 0. We can use other notations. thereby replacing this y prime prime to the 2y all over the x squared, which is the second derivative of y with respect to the second derivative of x, minus 3, and this is just dy by dx, first derivative, equals to 0. So out of the two ways you write it, it's still correct. Your instructor will still give you the mark for it. So this is exactly how we find the differential equation, thereby using the elimination of arbitrary constants method. So thanks ever so much for watching. See you in our next video.